any other items, Paul, we need to cover before we dive in?
Well, you're this guy, Brian Timoney, currently Senior Developer Relations Engineer at IQGO, but longtime PostGIS Day attendees will know him as the unapologetic spreadsheet evangelist and notable KML dead ender. Brian has
Well,
toured with the
these
Grateful
are
Dead.
the KML is an official OGC format, please. And in a world where shapefiles still exist, I'm not going to apologize for the mixture of data and styling in
Okay,
KML.
okay,
We've already gone off track, so I'm just going to jump in, Paul, and get
go.
started. And users or viewers will note my rather aggressive title. And this stemmed from telling a tech adjacent friend about my participation in PostGIS Day and how, it's fun. You do live demos, you risk catastrophic embarrassment if your demos don't work, etc. And then I mentioned that, the videos of past PostGIS Day presentations are online. And this tech adjacent friend said, wait, there's videos of you on YouTube ranting about SQL for like 25 minutes straight. And and friends, I took umbrage. I took umbrage. Because first of all, I'm not ranting. I'm emoting enthusiasm. So that's clarification number one. Clarification number two is spatial SQL is awesome. So that got me thinking to a larger issue of language and how we fail to update our priors, if you will, as technology changes, but our dusty, musty concepts of words stay the same. And I would say that is very much the case of database. So for 99% of the world, the database is an extremely tedious, boring concept. But for us, we all know Postgres is not just a passive storage mechanism for rows and columns. It is a dynamic platform that helps us glean knowledge and insight from said rows and columns. So let's acknowledge that um, less enlightened folks have an antiquated legacy definition of database, and that ours is the evangelical mission to help correct that. So I'm going to do two sets of demos today. And what better way to demonstrate the dynamic nature of Postgres and PostGIS of being a dynamic platform for data analysis, and data insight than to hooking it up specifically to the context of it begins with an A, it ends with an I, and it's two letters. Can you play Wheel of Fortune? And we will be doing AI. Now, for those who are watching live, we just had a presentation with Claude. Claude will make a reappearance. My bold prediction for 2030 is that Claude will be the most popular desktop GIS software. That's my prediction. Anyway, but I have 25 more minutes of presentation. So we will do a Claude demonstration and then we will take it up a notch. That is the plan of the day. So before I tell you about the um, great technology of MCP, let's just get Claude going on our local database. So I'm going to say, please tell me about my Postgres database public schema and what tables I have. And so now all of these demonstrations you'll see today are on an extremely underpowered, cheap Windows laptop. with a street value of $71. And so there's no GPU. It's minimalistic CPU. So it'll add an extra layer of excitement. So what's going on? It's connecting to my local database. It says I have geographic data tables, and that's awesome. Um, and if you guys remember last year, this is my PostGIS day presentation from last year. All the tables, I still have them. Just go back to the same database. Why keep it complicated? All right, so look in the France table and give me the five most populous departments using 2008 data. All right. So why don't we, while Claude's pondering that, why don't we go ahead and talk about MCP? And I assume other people have talked about this. This is Model Context Protocol. And you can see there's a bunch of lovely people on YouTube who are ready to help you out with that concept. Basically, LLMs need context to understand specialized tools. So the Postgres MCP provides a context for which it can understand what's in your database and even do some queries. So, oh, look at this. I have I have data straight out of my uh, thing. Well, okay, you just can't give me answers. Uh, like show me the sequel because like we're all sequel people here. Um, and the idea of in our deterministic all right, so it selected all the fields, but it did choose pop underscore 2008 to give me 2008 data. All right, I'll let that stand. All right, next question. Departamentos con la menor cantidad de habitantes en 2008. Now, for those of you paying close attention, that's Spanish with a Philadelphia accent. I'm sure it resonates um, around the world in Spanish-speaking countries. But the idea of MCP plus Postgres, we have foreign language support out of the box. And here is the interpretation. And there are our five departments with the least population in France. So we have MCP, we have Claude, and now we can talk to we could talk to our Postgres database. We saw DB browsing, it told us our tables. We did a basic select. We did multi-language. Now let Claude just grind on an infographic. Claude, we need an infographic with the most interesting insights from the France population data. Now, doing an open-ended prompt like that to Claude, it gets at the what has already been covered in other presentations, the probabilistic nature of LLMs. Those of us who work in the data world, we like deterministic things where repeatable processes that are audible, audited, can be audited, better yet, and where steps happen the same way each time. Now, for instance, let me expand this. When I was doing this particular demonstration, um, it used Python and Matplotlib to come up with an extremely cool graphic. And now it looks like it's just crunching on a bunch of HTML. So that's a polite way of saying I have no idea what this final graphic is going to be. And again, it gets to the heart of when we're using LLMs kind of solo without supplementary tooling, um, it can it can do all sorts of unexpected magical things. Let me open this in Google Chrome and see what this infographic looks like. Wow, look at this, friends. Fastest growing departments, declining departments, population extremes, key insights. Wow. All right. Well, if you like summary statistics, you'll love my infographic. So that's kind of awesome. And again, this is Claude plus just the generic Postgres MCP. Tell me something about my database, answer some basic questions, give me some SQL if I want to audit exactly what you think you're doing, and then generate a nice graphic with me expending exactly zero energy. Your sales and marketing team will love that, especially with that level of effort. All right, let's move on. What's next on the slides? Slide. Ah, friends. So, Claude, we saw the interface. We saw me typing in generic stuff into the interface, some questions. So that's me, the interface, interacting. We have a connection to my localhost database, so I understand how all that works. What if I told you that just like in any good horror movie, the call is coming from within the house? And what I'm speaking of specifically, friends, is a tool created by our intrepid host, Paul Ramsey. And this tool, PG-SQL dash OpenAI, lets us access a via HTTP APIs to our favorite language models directly in the database. And now you're saying, no way, that's impossible. Well, the idea of making HTTP API calls from within a database, that horror film trope, that's not a casual metaphor that I chose, friends, because for many people, the idea of just managing network traffic inside your database is anathema. But we're intrepid explorers. So what's happening here? We're using Paul's HTTP tool to communicate with the outside web world using um, using the libraries he created, which is a polite way of saying if anything goes wrong here, it's all Paul's fault from here on out. Claude did its job. We'll see if Paul can step up. So I have Olama installed locally on my severely underpowered machine. There's your Windows command prompt. That interface hasn't changed in 25 years minimum. So you can see I have 4 models downloaded locally. These are all open source, free to use. And then I have DeepSeek Cloud. My laptop isn't big enough to host DeepSeek, so I am connecting through it through Olama's cloud infrastructure. We will see that shortly. So I got this small m prompt, and I'm just going to run a select statement from my database IDE within my PostGIS database. This is crazy. Now, the first thing notice about my underpowered laptop is when I'm hitting the local model, The response time is, how should we say, leisurely. Um, and I will remind you once again, this demonstration went perfectly um, before this presentation started. So we're going to wait 10 more seconds before we get our timeout, but every experience is a learning experience. And I'm just asking it, what are the three colors found in the US flag, right? Oh, we got timeout. So our local models on our laptop that leaves much to be desired in the performance ain't going to work well. All right, so let's go to the Olama Cloud option. And again, I'm just setting my parameters. So my um, so we're just changing the model we're hitting. So we're hitting DeepSeek, friends. This is cutting edge. This is the open source, one of the open source Chinese models that could possibly undermine the multi-billion-dollar US-based LLM industry. But, let's live dangerously and let's change the prompt. I am a GIS analyst who is trying to disambiguate US cities with the same name. Where is this US city named Portland associated with the lobster industry? Respond only with a valid GeoJSON point object representing the geographic location. Can Chinese open source technology give us an answer to this? Friends, that response came back from Olama Cloud in 2 seconds. Let's just copy it and then let's go and verify this fragment of GeoJSON that was sent back. Okay, so you see the format of how it got sent back. And friends, let's delete that. Oh, not Portland, Oregon, friends, Portland, Maine. An open source Chinese LLM model could disambiguate Portland, Oregon from Portland, Maine. This is amazing. We live in a days of miracle and wonder. Let's go back to our database IDE because I want more of this. Let's up the ante. I'm a GIS analyst, blah, blah, blah. Where is the US city named Frisco most associated with the skiing industry? Only give me a GeoJSON object. Friends, this is what we call a hometown question because we have Frisco, Texas. We have Frisco, Colorado. And of course, at the risk of intentionally offending our friends on the West Coast, we have San Francisco, that is often called Frisco. Friends, it zoomed right into Colorado, Frisco, Colorado. So the idea is twofold. LLMs are great at parsing language. So if you need them to disambiguate and give some reasoning about, hey, what do you really mean? What location? It's a great option. And then secondly, LLMs are really good at formatting text and giving you responses. And this GeoJSON approach I stole from Regina Obe at Phos4G 2 weeks ago when she presented it. And I'm like, great, let's just get GeoJSON back. And the great thing about it is, since we're making these requests from inside our Postgres IDE, if we were so inclined, we could just take that data. We could do a simple regex query to make sure we're only getting the JSON fragment, and we could use it as a spatial object, convert it to a native Postgres, WKB geometry, et cetera, et cetera. But friends, let's up the ante. Like GeoJSON of point locations, kind of cool. Maybe, I don't know. But you know what's cool? What's cool is if we have images that we want to analyze. So we're going to change the model that we're hitting through Paul's wonderful tool that has performed quite well. Let's see what OpenAI, what model we're hitting. OpenAI GPT-4 Turbo, which sounds awesome. Okay, what do we? What's the task at hand here? Well, let me find the correct window, which is not clear to me on my layout. Oh, there we go. So we have this image, and it's on the internet on one of my websites. So it's just a JPEG sitting out there. Can we send a request from inside Postgres to tell us what is inside that image? And you're like, all right, let's give it a try. GPT-4 Turbo. And we are watching the response. We are feeding it the prompt. I need you to analyze the image at the provided URL. We're giving it the URL, and then oh, the image features a standard red stop sign prominently in the background, situated against a clear blue sky. Blah blah blah. Friends, that's pretty cool. My image lives elsewhere on the internet. GPT-4 Turbo can go out, and then it brings me back information about it. Okay, whatever. It's a picture of a flag. Who cares? All right, friends, this is the final trick. All right, I have this 177 kilobyte JPEG of the urban rural interface in Arapahoe County, Colorado. This is the end of the subdivision. I have a red polygon around a suburban house, and then I have a blue polygon around a field. So, is the current state of AI technology able to tell us something intelligent of this not very high resolution JPEG, 177 kilobytes? Can it give us back useful information? Let us go to the prompt because we're going to have to be a little more verbose this one. All right. Tell me the man made structures within the red polygon, then the structures within the blue polygon, and give me the result as a JSON object. For the red polygon, add an ID property to the JSON response with a value of 33203. For the blue polygon, add an ID of 9903. Here's where the image lives, and use that same model. Friends, what is going to come back when we do something like this? Let it. I'm waiting with bated breath. That's BATED. Okay. I'm going to copy this and then put it in a wonderful word interface. Okay. Here is the response. Now, notice, like I just wanted JSON, LLMs can't help themselves. They give you a bunch of text before they give you the JSON. But here's the deal, friends. Red polygon, it tucked in that ID for me of 33203, gave me the structures, gave me the blue polygon, and said there's no structures, and area appears to be a barren field. So imagine you're in an assessment office, and every year you have a certain number of parcels. Like, did anyone build anything on it? You might have some permit data, and you could generate these aerial views with the parcel boundary and send it to an AI to do the analysis and give you structured data back. Structured data that comes with ID tags that you can then link back to your source parcel data. Friends, here is what I'm going to leave you with. We already did that. We used Olama models, open source, both local and cloud. Local didn't work because I have a bad laptop, underpowered. OpenAI did the image analysis. Here is my go-to visual metaphor of where we are at currently with AI. Most of us are in the bottom left-hand corner watching, some with cameras, all of us expecting something mostly catastrophic to happen. We have a single person actually on the wave of AI surfing. It appears this surfer, he or she, is going to do well. And then, of course, in the background, you see a couple people on wave runners. Those would be the upper management of your organizations that you work for, cheering you on and urging you to catch that wave of AI. And with that, I thank you for your attention. That's all I got, Paul.
That's it.
Right.
Well,
No
thanks.
Excel. No Excel.
Oh, that's
It's
true. No Excel, but prediction that Claude is going to be the GIS of the future. Could it finally become true that metadata is actually going to be important?
that. So this is my dearest hope. So as you know, I evangelize for the APIs in the network utility and network telecom space. So and I don't think I'm breaking news by saying telecom and utilities have some of the most problematic data quality anywhere in the geospatial landscape, right? But again, cleaning up your data, that sounds like Saturday chores on steroids. Will AI be enough of a payoff for organizations for them to invest significantly in data quality? That's issue number one.
Hmm.
And will AI help the way data is collected in the first place to ensure data quality standards as it works its way into our PostGIS data stores? That is the hope and dream that sustains us all in these otherwise dark times, Mr. Ramsey.